What if we told you that you could actually fall off from a particular place on Earth and fall into oblivion? Or that we could experience sideways rainfall at everywhere on Earth apart from the North Pole? That sounds crazy, right? Have you ever wondered how one-sided our water bodies would look like if the Earth was flat? Guess what? It is not totally impossible, as that could be some of the crazy effects one would have been facing if the Earth was actually flat. But on the bright side too, hurricanes could be a thing of the past. Curious to learn more about the shape of the Earth? Stay tuned as we delve into the many possibilities of the globe if the Earth was actually flat. Humans have known for thousands of years that the planet is round, yet the belief in a flat Earth refuses to die. Members of the Flat Earth Society and several celebrities, including Atlanta rapper B.O.B. and NBA player Kyrie Irving, claim to hold such beliefs. Let's examine, then, how the well-known principles of physics and science would work, or not, on a flat Earth. Gravity fails first of all. A pancaked planet might not have any gravity. It's unclear how gravity would work or be created in such a world, says James Davis, a geophysicist at Columbia University's Lamont Doherty Earth Observatory. That's a pretty big deal, since gravity explains a wide range of earthly and cosmic observations. The same measurable force that causes an apple to fall from a tree also causes the moon to orbit the Earth and all the planets to orbit the sun. People who believe in a flat Earth assume that gravity would pull straight down, but there's no evidence to suggest it would work that way. What we know about gravity suggests it would pull toward the center of the disk. That means it would only pull straight down at one point on the center of the disk. As you got increasingly far from the center, gravity would tug more and more horizontally. This would have some strange impacts, like sucking all the water toward the center of the world, and making trees and plants grow diagonally, since they develop in the opposite direction of gravity's pull. Solar problems. Then there's the Sun. In the scientifically supported model of the solar system, the Earth revolves around the Sun because the latter is much more massive and has more gravity. However, the Earth doesn't fall into the Sun because it is traveling in an orbit. In other words, the Sun's gravity isn't acting alone. The planet is also traveling in a direction perpendicular to the star's gravitational tug. If it were possible to switch off that gravity, the Earth would shoot away in a straight line and hightail it out of the solar system. Instead, the linear momentum and the Sun's gravity combine, resulting in a circular orbit around the Sun. The flat Earth model places our planet at the center of the universe, but doesn't suggest that the Sun orbits the Earth. Rather, the Sun circles over the top side of the world like a carousel, broadcasting light and warmth downward like a desk lamp. Without the linear, perpendicular momentum that helps generate an orbit, it's unclear what force would keep the Sun and Moon hovering above the Earth, Davis says, instead of crashing into it. Likewise, in a flat world, satellites likely wouldn't be possible. How would they orbit a plane? There are a number of satellite missions that society depends on that just wouldn't work, Davis says. For this reason, he says, I cannot think of how GPS would work on a flat Earth. If the Sun and Moon just loop around one side of a flat Earth, there could presumably be a procession of days and nights. But it wouldn't explain seasons, eclipses, and many other phenomena. The Sun would also presumably have to be smaller than Earth so as to not burn up or bump into our planet or the Moon. However, we know the Sun to be more than 100 times the diameter of the Earth. Removing heaven and Earth deep below ground, the solid core of the Earth generates the planet's magnetic field. But in a flat planet, that would have to be replaced by something else. Perhaps a flat sheet of liquid metal. That, however, wouldn't rotate in a way that creates a magnetic field. But in a flat planet, that would have to be replaced by something else. Perhaps a flat sheet of liquid metal. That, however, wouldn't rotate in a way that creates a magnetic field. Without a magnetic field, charged particles from the Sun would fry the planet. They could strip away the atmosphere, as they did after Mars lost its magnetic field, and the air and oceans would escape into space. Tectonic plate movement and seismicity depend on a round Earth, because only on a sphere do all the plates fit together in a sensible way, Davis says. Movements of plates on one side of the Earth affect movements on the other. The areas of the Earth that create crust, like the Mid-Atlantic Ridge, are counterbalanced by places that consume crust, like subduction zones. On a flat Earth, none of this could be adequately explained. There'd also have to be an explanation for what happens to plates at the edge of the world. One could imagine they might fall off, but that would presumably jeopardize the proposed wall that prevents people from falling off the disc-shaped world. Perhaps one of the most glaring oddities is that the proposed map of the flat Earth is totally different. It places the Arctic at the center while Antarctica forms an ice wall around the edges. In such a world, travel would look very different. Flying from Australia to certain parts of Antarctica would, for example, take forever. You'd have to travel over the Arctic and both Americas to get there. In addition, certain real-world feats, such as traveling across Antarctica, which has been done many times, would be impossible. Falling flat, contrary to popular belief, it's a misconception that many societies of serious, educated people ever actually believed in the flat Earth theory. With extraordinary few exceptions, no educated person in the history of Western civilization from the 3rd century BC onward believed that the Earth was flat, historian Jeffrey Burton Russell noted in 1997. A round Earth appears at least as early as the 6th century BC with Pythagoras, who was followed by Aristotle, Euclid, and Aristarchus, among others, in observing that the Earth was a sphere. Like the other planets, the Earth is a sphere. It rotates around its own axis slowly but continuously, and completes this rotation about once every 24 hours. As the Earth rotates, part of the Earth is facing the Sun, and part of it faces away. This is why some parts of the world have day and night at different times. There are a number of reasons why scientists know that the Earth is round and not flat. It turns out that we can test many of these reasons out for ourselves, too. If the Earth was flat, we would be able to look out and see very far, assuming that there were no buildings in the way. We could see another city that's hundreds of miles away, or a ship sailing out to sea. The boat would stay in view no matter how far out to sea it went. However, if we look out when standing on the ground, we can't see that far. We can't look out into the distance and see a town that's miles away. And a ship will slowly start to disappear from view as it gets farther away. This is because the Earth is round. Things in the distance are not visible because there is a curve to the landscape. One way to test this is to watch the sunset. Find a spot where you can see the sunset, and also have a place close by where you can safely move higher, such as a tree or building. Or even start laying down and then stand up. On the ground, the sun will eventually disappear beyond the horizon. When this happens, quickly go to your higher spot. From there, you'll be able to see the sun again for a brief time. You have probably seen that when the sun is out, it causes a shadow to form if it hits something. It turns out that we can use shadows as another piece of evidence that the Earth is round. If the Earth were flat, then shadows would be the same length, regardless of location. This would mean that the sun is hitting all places on Earth at the same angle, resulting in the same shadow. However, it turns out that this is not the case. If we were to place two identical sticks in the ground in two different places on Earth, we'd find that the length of their shadows differs. This is because the Earth is round, and so the way the sun hits each location will be a bit different. This also explains why the sun sets at different times in different locations. The sun is in a different position in relation to different locations. And so the timing of when it will lower in the sky and eventually disappear behind the horizon will change. This is also the reason that different parts of the world have different time zones. As one part of the world is facing the sun, another on the opposite side of the Earth is not. For example, the time in New York, United States is 12 hours different than the time in Beijing, China. For parts of the world that are closer together, the difference in time will be less. During a lunar eclipse, the Earth passes between the moon and the sun. When that happens, the sun projects Earth's shadow onto the moon. When this happens, you can actually see the Earth's shadow if you look up at the moon. If you do this, you'll see that there is a round shadow, not a flat one. A follow-up question might be whether the Earth could be flat and round, like a pancake. This would cause the shadow on the moon to be round, but the shape of the Earth to be flat. If the Earth were flat but rotating, its shape would be different for eclipses at different times of the day or night. Sometimes it would appear only as a line. The rest of the time it would appear like an oval or circle as it's spinning. However, we know that the shadow the Earth casts on the moon during an eclipse has always been circular, regardless of time of day. This supports the idea that the Earth is a sphere. These are just a few testable ways we know that the Earth is round. From high altitudes, or even from space, the true shape of the Earth can easily be seen. Its dimensions can be measured. Its radius of curvature in all directions can be calculated. The imperfections and departures from sphericity are directly observable by our instruments. If you travel far enough away from Earth, you can observe an entire hemisphere at once, even watching the planet rotate on its axis in real time. At right around 12,700 kilometers, 7,900 miles, in diameter, our world is undoubtedly a sphere. But what if you had never been to space, or high enough up to see the Earth's curvature yourself? What if you had never circumnavigated the globe, done the Eratosthenes experiment, or heard about the Shaquille O'Neal experiment that anyone can perform? Believe it or not, there are still a number of simple observations you can make that wouldn't occur if the Earth were flat. Here are the top simplest ones. Facts that would have to be true if the Earth were flat. Lunar eclipses don't occur only at midnight. Take a look at the shape of the Earth's shadow during a lunar eclipse, particularly during a partial phase. Do you notice how the Earth's shadow always appears to be a piece of a near-perfect circle? If the Earth were a flat disk, that means there's only one possible orientation that the Sun-Earth-Moon alignment can take place in to create a circular, rather than elliptical, shadow, with the Earth's disk perpendicular to the Sun-Moon plane. This means the Sun would need to be at the midnight position relative to the night side of Earth, and yet lunar eclipses occur at all different times depending on where you are on Earth. The flat Earth can't explain that. Different stars are visible from different latitudes. Look up at the night sky from a very high, northern, latitude location, and you'll see the Big and Little Dippers, the bright orange giant Arcturus, and the Pleiades, among other sights. Yet if you head to the South Pole, none of these celestial sights are visible, but you can see Alpha Centauri, the Magellanic Clouds, and the Southern Cross, all of which are never visible to most Northern Hemisphere skywatchers. If the Earth were flat, everyone on the night side of the Earth would see the same sky. This is another observation that the flat Earth can't account for. You cannot see Kauai Kini from the peak of Mauna Kea. Mauna Kea, the highest peak in Hawaii, the summit of the Big Island, offers incredible views. With nothing but the ocean around it, and a few other nearby islands, you should be able to see extremely far away. The island of Kauai has the 7th highest point in the Hawaiian Islands, the peak known as Kauai Kini. If you were to draw a straight line from Mauna Kea, elevation 13,796 feet, to Kauai Kini, elevation 5,226 feet, it would span a distance of 303 miles. However, you cannot see one from the other, which you would absolutely be able to do if the Earth were flat. With a curved Earth of its measured radius, the line of sight limit for those two elevations caps out at 233 miles. Only with a curved Earth is one invisible from the other, and this is true for any two mountain peaks with clear line of sights from one to the other. Sunsets and sunrises happen at different times depending on your longitude. If the Earth were flat, then someone in New York and someone in Los Angeles would see the sun rise and set at exactly the same time as one another. But in practice, the difference is approximately 3 hours. Not only that, but at every point in between, the sun rises, sets at a different time, something that could not happen if the Earth were flat. The fact that it can be evening in New York and late afternoon in Los Angeles, or morning in New York while it's still before dawn in Los Angeles, is something that a flat Earth can't account for. If the Earth were flat, these four phenomena would be very different, and yet they are so simple to verify that any flat Earth believer cannot possibly doubt their veracity. Whether it changes anyone's mind is up for debate, but without resorting to space, circumnavigation, or any advanced scientific experiments, you can experience a whole handful of phenomena that a flat Earth can't account for. With a flat Earth, we'd only get lunar eclipses at midnight, everywhere would have the same seasons, every location would see the same stars, all high mountain peaks would be visible from one another, and every place on your side of the Earth would see sunrise and sunset at the same time. Since these are false, so is the flat Earth. If this helps even one person challenge their belief that the Earth is flat, it's a remarkable win for knowledge. But don't bet on it. Like the old saying goes, you can't reason someone out of a position they didn't reason themselves into.